Hi everybody, this is 4K Energy and Systems. So we got this scenario here. Consider a car that is initially moving on a straight roadway. The road may be an uphill road, a downhill road, or a flat road. The driver of the car may be pressing the gas pedal, the brake pedal, or neither pedal. The only energy transformations that can take place are chemical energy becoming mechanical energy when the gas pedal is pressed. So more specifically, chemical energy becoming kinetic energy initially. And the mechanical energy becoming thermal energy when the brake pedal is pressed. Chemical energy levels may be thought of as the gas gauge level. That's sort of a hint there for you. So what we're going to do here is we're going to fill out these different scenarios here and think about what's going on and what our different energy bar charts should be here. All right, so part A, we got a car that's traveling downhill while the driver presses the gas pedal. So the mechanical energy of the car, so if we're just talking about the car, then it can only have, its only mechanical energy is from kinetic. So if we're going downhill while pressing the gas pedal, then our car's kinetic energy is going to be increasing. While the mechanical energy of the car earth system, well, that's also increasing. A lot of people want to instinctively hit here constant. That would be true if they were just coasting down the hill, but it says they're hitting the gas pedal. And so they're getting additional energy from the gasoline's chemical energy there. So I added these little lines here with 5 and 10 bars there just so it'll be a little bit easier to see on here, because how much there is very important for what we're getting ready to do here. Okay, so we've got a full tank of gas. Let's say I'm going to draw that all the way up to here, up to the 10 line, and I'm just going to write on there and on top of that we have 10 bars of chemical energy. Now, it doesn't say whether we're already moving when we're going down the hill. I'm going to pretend that we, well, let's just say this. Let's just say that we start from rest. That will make things a little bit easier. So we have no kinetic energy. If we're talking about we're up on a hill, then the gravitational potential energy might be something, let's say, like 4. And then we have no thermal energy because the brake hasn't been pressed at all. So now, 2 things are going to go on. As the gravitational potential energy goes down, that's going to become kinetic. I think we're used to that. But also, since we're pressing the gas pedal, this chemical energy is going to become kinetic energy. So I'm going to lower this down here, this amount of chemical energy, and I'm going to lower it down, let's say, to 6. So I used up 4 bars of my chemical potential energy. Those bars have to be made up somewhere. So I'm also going to pretend that I'm at the bottom of the hill. They don't really say if you go partway down the hill or whatever. So I'm just going to say you're all the way down at the bottom of the hill. So I've given 4 bars of chemical energy into kinetic, and I've also given 4 bars of gravitational potential energy into kinetic. And so that means all together, let's see here, 1, 2, we're going to have 8 bars of kinetic energy there. Again, what has happened is 4 of those bars have come from the gas, and 4 of those have come from the gravitational potential energy there. Okay, so now part B here. So in this scenario, it says the car is traveling uphill while the driver presses neither pedal. So no gas, no brake. So the mechanical energy of the car only. Remember, that's just kinetic energy. If we don't press either pedal and just coast up the hill, we're going to lose speed, and we're going to have our car's velocity and therefore kinetic energy decreasing. While the mechanical energy of the car earth system that would be constant, because in that case, our kinetic is becoming potential, and we can keep it there. Okay, so now I've got a full tank of gas here, up to the 10, I'm going to say, but I never pressed the gas pedal, so I'm going to go ahead and fill that out over here. That stays at 10. So I've got some speed at the bottom. I'm just going to fill that up nice and evenly to the halfway point here and say that is 5 kinetic. And as we go up, that's going to become gravitational potential. Now, they never said that we come to a rest, but I'm going to assume that we get just to the point where we just stop and all of our kinetic has converted over into gravitational potential. But none of our mechanical is lost, right? It just went from here over into there. We didn't hit the brake, so no thermal energy. All right, let's keep going here. Part C. In this case, they've sort of switched it up. Instead of telling us what it's doing, they ask us what is going on with the energy. They're going to tell us what's going on with the energy, and we have to tell them what's going on with the car. So the mechanical energy of the car, only the car is constant. Oh, say if that's constant, then the kinetic energy is constant, which means the velocity is constant. And the mechanical energy of the car-Earth system is decreasing. Okay, so even though our velocity is constant, our car-Earth system is decreasing. So how can that be? Well, the way that this could happen is if we're going downhill, let's say, because that's a way to lose energy of our car-Earth system, but we must be hitting the brake as we go down. We're on cruise control. We're keeping a constant speed. So going downhill at a constant speed will keep our kinetic energy constant, and then we're losing energy from the Earth system. By the way, you couldn't do it going up the hill and then pressing the gas at just the right speed to keep the speed constant, because then we'd be gaining potential energy, and our energy of our car-Earth system would be increasing in that case. All right, so let's show what's going on here. We never hit the gas pedal, so once again, I'm gonna draw chemical energy at 10 here, and I'm gonna draw it at 10 here. You could have picked any number, again, it doesn't have to be 10. Our kinetic energy is constant in both cases. So I'm gonna draw it as a 5 right here to keep it simple, and a 5 right here. Now, in this case, what's a little bit different is our gravitational potential energy. We were on top of the hill before. Let's just say we had 5 bars of gravitational potential energy and we get to the bottom. Because we were hitting the brake, that doesn't build onto our kinetic energy because we're going at constant speed. That goes into now our thermal energy. And this, by the way, is what a hybrid car helps you with. A hybrid car helps this braking energy from going from kinetic or potential into thermal. It saves that and puts it into electrical potential energy. It's kind of like it adds it back into the chemical energy, and you can tap back into that. Okay, last one here. So now in this situation, again, they're going to tell us about the energy. We tell them about what the car is doing. So the mechanical energy of only the car is decreasing. That means kinetic energy is going down. That means velocity is going down because the car by itself can only have kinetic energy. The mechanical energy of the car-Earth system is increasing. So even though our kinetic energy is increasing, our car-Earth system's mechanical energy is going up. So we must be getting a bunch of gravitational potential energy by going up the road. So in this case, the car is traveling uphill to gain that additional mechanical energy, and then we must be hitting the gas too. Now, what I know we have to be hitting the gas. Why can't we just be coasting? If we were coasting, then this decrease of the kinetic energy would equal the increase of the gravitational potential, and the car system would stay constant. I know I'm not hitting the brake because that would decrease this and decrease the kinetic energy. So I must be hitting the gas, and this hitting the gas is outpacing this loss of velocity here. So now let's look at this last one here. Our chemical potential energy in this case is, we never hit the, we're hitting the gas. So let's say we had 10 of this chemical potential energy to begin with, and let's say we get it all the way down now to 5 in the end. So we use up half our tank of gas. Our kinetic energy is going down. So let's say we start it with a certain amount, let's say 5 bars, and let's say in the end we only go up to 2 bars there. Our gravitational potential energy must be increasing, and it's got to equal the loss of both of this one here. And so if we lost 5 from here, and we lost 3 from here, and then we go up to 1, 2 here, all right, we go up to 7 here. Part of this increase is coming from the loss of kinetic energy, and part of this increase is coming from the loss of chemical energy in the form of the gas.